Okay. Okay, so next page. So we're going to look at surds. What exactly is that? Well, that is something that looks like this. Wait. Now, before anyone asks, yes, American educated students, you can call them radicals or whatever it is you do. Yes, you're not my first international students. So that's what we're going to look at then, is surds and all the different rules with them. It's not. Okay, so the first one is just basic simplifying. So, if I had a surd like this, how can I simplify it? Now, wrong answer. Yes. Yes, yeah. You have to break the 108 into different factors. So, students sometimes have difficulty with this, so this is how I recommend doing it. You take the 108 and you split it into any two numbers except one. So, say 54 maybe and 2. Now, you can't continue with the 2, so you stop with the 2. The 54... Yeah, well, 54 you could say
6 and 9.
6 and 9 would do it, yeah. The 6, yeah, 2 and 3. And the 9, 3 and 3. So what you do, oops, sorry. These are all the numbers that if you multiply them together make 108. So that 108, you can write that as 2 multiply, 2 multiply, and then there's 3 of those. Okay? So you try to group them together by pairs. So you have 2 here, so that's 2 squared. And you have 2 of them here as well, so that's 3 squared. You only have 1 of them here, so that's 3. Square root and square cancel. So you're left with 2, 3, root 3. So the answer is 6 root 3. That's the simplest we can make this. 6 root 3.
Why isn't the other 3 in the square?
Why does this stay separate to this? Yeah, what you're doing is you're grouping them together to make squares. So that you can see what cancels clearly. Yes. Listen, no, there's too much talking now. So, this here, this technique here, I am convinced that a lot of people in this room, although they probably don't remember, I'm convinced that a lot of people have done this in elementary school, this tree here.
Yeah.
Yes. It's called prime factorization, prime factors. These numbers here, 2, 3, 3, 3, 2, they're all called prime numbers. Okay. I'll do another example. No, actually, I'll give you one to try. Yep.
1 is not a prime number, right?
Correct. Yes.
Is or is not?
Is not. Yes. Sorry, maybe to make that clear. The reason 1 did not appear here is because 1 is not prime. Yeah, good to know. Right, let me give you one to try. So the one I'd like you to try to simplify for me is square root. Yeah, I'll write that vocabulary down. This is called, it actually translates, I'm pretty sure it translates the same in your native language as in square and the root of a tree. Square root. But a lot of people just say root, okay, but square root. So square root 245, simplify that for me. Using the tree, yeah? Good, and did you write the tree down? I want to see that too. Go.
In the exam I have to draw the tree.
No, not in the exam, but just for today.
Okay.
Yes.
Drawing the tree.
5 is a prime number, right?
Yes. Got it?
It's a
7 root 5. I'll check it now, but let's see, 749, 5. Yeah, yes it is, yeah, 7 root 5. Yes, that's what you got as well, isn't it? Yes? So, no, not there yet. One more minute, and then I'll do it. You got it, good job, yeah? You didn't have it, yeah. Okay.
7 root 5.
Yes, all right, okay. I don't think I need to do it then. A lot of people got it. 7 root 5 is the answer.
So, how do we put it as an answer?
Oh, well, the question would have said simplify, so that's it, simplified.
Do you always put the smaller number in the bracket and the radical?
Not always. It just ends up that that's usually the case, but no. No. Okay. Next one now. So we have square root 624 plus square root 39. So we want to simplify this. So it's actually the same situation. First we have to simplify 624. So let's see. That would be 208 times 3. Yes. That's 104 times 2. That's 52 times 2. That's 26 times 2. Okay, so that's 13 times 2. So it's 13 and then all these 2's here and a 3. So this would be square root 13, 2 squared, and a 3. 13, 2 squared, and a 3. So we end up with 4 root 39. So there's nothing else for me to do except combine. Because if you think about it, it's like you have one of these. Okay, you need to write that down. It's the same. It's the same thing, really. When you write that down, when you're finished, I'd like you to try this one.
How come we the 59 square root into another number? We only do it on one number?
What do you mean? Exactly.
Like, we only did on square root 624, like the other number, square root.
Oh, I would have continued and I would have done the same thing with the other number, but I saw that, I already have a 39 root, so I can now add them together. Yes, but maybe in this case here, I think this is one where both need to be simplified. So I want you to try this next one, please.
there any other way from this one? Is that
No.
one that's on the-
You need to simplify each one and then combine them. Yeah. The next one? Okay, let's have a look at it. So 128, that's 64 by 2. That's going to be 32 by 2. You know, if you keep going down, it's going to be just 2 multiplied. 2, 4, 8, 16, 32, 64. There's going to be 6 2's at the end. If you continue with this, etc., you'll end up with the number 2 6 times.
Not 7?
Oh, hang on then. Oh, 7 times, sorry. 7 times, yes. And then this one here will be 4, 2, 4, 8, 5 times, isn't it? Yeah, so this one here is square root 2 squared, 2 squared, 2 squared, 2. And then, what do we say here? 5 times?
Yes.
2 squared, 2 squared, 2. So that would be 2, 2, 2, square root 2, minus 2, 2, square root 2. 8 root 2, minus 4 root 2, 4 root 2. Yes, indeed. Just to be really clear, I've been using this rule, but I just want to make it explicit. Square root A multiply B equals square root A square root B. And square root A plus B, no. Bad student. Bad. Don't do this. It's a no. Yes, no dinner for you. Don't do that. That's bad. Very, very bad. The first one is right. The second one is wrong. If you look in the second question, the idea is the same for all of them. Before you combine with plus, minus, multiply, or divide, you must simplify the surd. Okay? So, for example, here, if I had square root 500 divided by square root 20, you can simplify the top and the bottom. Let's see if we can try and do this in our heads. This would be 5 times 100, 10 root 5. No, but I want to simplify each. But I want to. 100 times 5, 10 root 5. And then here, 5 times 2 root 5. 5. Yeah? So again, you simplify before you combine. That's the idea in the second question. Okay, I'll go on to now what number 3 involves. So it's multiplying, but it's a little bit more complicated. And I've seen number 3 in the exam as a short question 3 or 4 times now. So I mean, it's, you know, it has been something that has come up in the past, and it's come up more than once. Okay. So next type, I'll do a difficult looking one that has, yes, like this one here. Square root 48 plus square root 5, square root 3 plus square root 125. Focus here. Now, yes, it is true, you still do it in the same order that we have been doing it in. But before you do that, we should simplify each one. It will make the multiplication easier. So, 48, that's 24, 2, that's 12, 2, and the 2 just comes down, we'll say. So that's 4 and 3. So that's 2, 2, 3, 2, 2. Okay. 5, no, that's it, just 5, 3, that's it. 125 as well. 25 and 6, 5, yeah, 25 and 5. 5, 5, 5. 5, 5, and a 5. Okay, so we have square root 2 squared 2 squared 3, 2 squared 2 squared 3, plus square root 5, and then square root 3 plus square root 5 squared 5. That's 1 pair and a 5, 1 pair, 1 pair, and a 3 for the first one. Come on, let's go down. So this is 4, because it'll be 2 multiply 2, 4 root 3 plus root 5, root 3 plus 5 root 5. Now, you can see now why it's a little bit easier, because this is root 3, this is root 5, this is root 3, this is root 5. So when you multiply it, it's a little bit easier. So let's do the first one. It's 4 root 3 multiply root 3. Then the second one is going to be 20 root 3 root 5. Then the middle one will be root 5 root 3. And then the last one will be 5 root 5 root 5. But what does root 3 make when you multiply them? 3.
Yeah.
So this is actually just 12. This is 20 root 15. This is root 15. And this is 5 by 5, yeah. 25. So the answer will be 37 plus 21 root 15. Now, like I said, I've seen this in the exam a few times. And the next question as well I've seen in the exam a few times. So please make note of this one carefully. Do you need me to scroll up? No? Okay. Well, I'll go up as much as I can here. So again, you simplify each surd and then you do your plus, minus, multiply, divide. Let me give you one to multiply here. Yes, I'll give you one to multiply. Can I scroll down? Yes? Okay.
No.
No? Square root 135 minus square root 2 multiply square root 15 minus square root. Don't take out the calculator. Now do this one for me. Hey, put the calculator away. It's not good for you. Well, in this case, I didn't need to, because I can see now I can combine them since they're both the same. But, yes, if this wasn't 39, I would have to, because then I still cannot combine these together. So usually, yes, in this case, I didn't need to. No, Tanish, resist, okay? Got it? We're just missing Jaffa, isn't it?
Yes,
Okay, are we nearly finished? seem stuck.
Yeah.
You're stuck? What's the problem? Really? Alright, go ahead. Yeah, yeah.
Is that the angel talking?
What?
Is it him?
Yeah.
Blue.
Who else do you think would say something ridiculous like that? We're getting finished now. You want to see it, yeah? I'll not do it at the moment. How are we doing? You have trouble with this as well? Yeah. Did you get it? Oh, hurry up, guys, come on.
Is it 20?
Well, I'm going to do it now. I'm just giving everyone a chance. So, 1, 3, 5. That would be 27?
No,
That's what I have. That's right, yes?
Yes, 27, you're right.
Yes. Okay. 27 is 3 and 9,
Yes.
which is 3, 3, 3, and a 5. Okay. 15, well, that's 3 and a 5. And then 18, that's a 9 and a 2, so that's a 3, and a 2. Yeah, so you'll end up with... What's wrong? Shh. What's wrong? Okay. Oh, well, there's many ways to get down to these numbers here. I think it's 27, yeah. You can check 5 multiplied 27. Is that 135?
Yeah.
So we have square root 3 squared 3, 5 minus square root 2 square root 3, 5 minus square root 3 squared 2. So that will be 3 root 15 minus root 2 root 15 minus 3 root 2. Okay, so when I multiply these, I'll get 45. 3 multiply 15.
So why is it 3 squared 3 by 5?
3 squared 3 by 5? That's this one here, isn't it? There's 3 squared, a 3 and a 5 for the 135.
I divided by 2.
You divide it by 2.
Why not?
2 doesn't go into 135.
Divide by 5. Oh, okay.
Oh, no points, no decimal points. No. Okay, so 3 root 15, that's 45. 3 root 15, so that would be 9 root 30.
Yeah.
Then this one here is minus root 30. And then this,
Minus 2.
sorry, which, this should be a minus here.
Yeah.
Yes, minus, and plus 12. Is it? Oh, 6, sorry, yeah, 3 by 2, yeah. So that would be 51 minus 10 root 30. Okay, now on to number 4. So like I said, in the exam, it's number 3 and number 4 that I've seen a few times. Can I scroll down? Okay. Now, you take one moment, 1 second. Okay, continuing now. So here, what we need to do is, let me give you some English here.
Rationalize.
Yes, you've heard this word before?
Yeah.
Rationalizing the denominator.
What does that mean?
Yes.
You make a more big square.
So,
You shouldn't have square roots in the denominator.
yes, that's what you want to do. So here we have a surd over a surd. And the way to simplify this is by rationalizing the denominator. What does that all mean? Well, first vocabulary. Denominator, that means the number on the bottom. Does anyone know the one on the top? I think I said this one. Numerator, denominator. Rationalizing means to remove the square root. So the way to do this is to remove the square root in the denominator. So now the next question is, how do you remove the square root? And this is how, you know?
Yeah, I think we multiply by plus 2 minus...
Very good, that's it, yeah. Conjugate, that's it, yeah. Yeah, very good, we know this vocabulary, that's good. So the way to simplify this is by multiplying the top and the bottom by minus 2 minus root 3 and minus 2 minus root 3. It is...
Is it plus 2 minus?
No, this is conjugate. This is conjugate.
Shh, hang on. First, by the way, minus 2 minus root 3, okay? So, if you have a degree in maths and a master's in maths, please put up your hand. Oh, okay, so I'm speaking now, alright? For conjugate, you only change the sign that's on the square root. That's it. Only this sign gets changed. So the plus root 3 becomes minus root 3. That's it.
So I don't.
Can't you keep the root sign but change the two sign? I think you can.
Yeah, that's the equivalent, and then it's like taking a minus out. Yeah. But that is not the usual way of doing it at all. But it'll give you the same answer in the end.
Yeah.
So we change the sign on the root. Now, it's very important that the numerator and the denominator is the same in the red. You see in the red?
Yeah.
Because what you're really doing is you're multiplying by the number 1. Because the top and the bottom is the same. So that's 1. So when you multiply a number by 1, do you change its value?
No.
No, you don't. So this will still have the same value, but we can simplify it. It can now change its form, but it still has the same value. So what we've done now is we've changed this into 2 multiplication problems. So we need to multiply the top and multiply the bottom. So, let's see, here. Now, what we have now is this problem on the top, and then we have this second one on the bottom. So let's do this one on the top. First, I think we can do something about this 147. That will be 49 by 3. So that's 7 root 3, is it? And this is minus 2 minus root 3. So I will get 20, and then I'll get plus 10 root 3, and then I will get minus 14 root 3, and then I'll get minus 21. Is that right? Yeah, so here I have minus 1, minus 4 root 3 on the top. Can you So on the top I have minus 1 minus 4 root 3 on the top. Now let's look at the bottom. Minus 2 plus root 3. Minus 2 minus root 3. So that will be 4, and then I get minus 2 root 3 plus 2 root 3 minus 3, so that would be 1. Okay? It doesn't have to be 1. But what's really important, listen, what's really important is that when you multiply the 2 in the denominator, the answer should not be a surd. See, that answer there has no square root. That always should happen. Why does it have no square root? It has no square root because, you see here in the middle, they cancel. You see that? That always happens. If that did not happen, it means you made a mistake. That always happens.
What always happens?
That you get the middle 2 cancelling, leaving you with just a normal number, so to speak, no square root.
But there is like a formula for a minus b.
Yeah, it's the
a
difference
plus
of
b
2
equals
squares.
a
Yeah.
squared minus b
I'm
squared.
showing it explicitly, but you're right, there is a formula, but it's explicit here.
Would the number always be 1?
No. Just in this case it was 1, but it would be a number without a square root. So like it could have been 2, 3, whatever. Yeah? Now,
Shouldn't have any square.
exactly. This denominator, the new denominator, should have no square root. The square root should now only be in the numerator. Yes?
Is that how the final answer should be?
No, you should do one more step after this. What you should do next, which is easy, is you should take each of these numbers and divide it by 1. Well, in this case it's easy because minus 1 divided by 1 is still minus 1, and minus 4 divided by 1 is still minus 4. So in this case nothing really has changed. But you know, sometimes, or most of the time, this is not 1. It's just an easy example to begin with. And somebody gave me the word earlier for this, conjugate it's called. So if I said, what is the conjugate of minus 2 plus root 3? The answer is, the conjugate is minus 2 minus root 3. Okay. Well, I'll just give you a minute to write that down. Or do you have it? Yeah. All right, let's just do some, just quickly check, make sure you're happy with conjugate. All right, so this is the surd, and then this is its conjugate. So what's the conjugate here? 4 minus root 3. Here?
4 minus.
Minus root 3 plus 4. Here? Minus root 3. And here?
4.
Yes. That's how I want it. That's how I want it. Yes?
Would it make a difference if it was radical 3 minus 4?
Oh no. If you change this to a minus, this is still a minus here. Yeah. No, it wouldn't make. You mean like here? No difference. If I made this minus, then it's just like that now. Yeah, no difference. The reason I want it like this is because I want, when I'm correcting your exam, I want it to be very clear. You're showing me you understand that the square root changes its sign. But in strange situations like this, in fact, if you didn't use the plus as the conjugate, it would still work. But I would much prefer you to write the answer like this, okay? So if I have this, and I want the conjugate for the problem, I need to see it like that, okay? To be clear. Let me give you one to try, to make sure you got this. I've seen this on the exam a few times, so it's important. Well,
Is everything on the exam?
what do you mean by everything? I suppose what I'm trying to say is there are some topics which are more frequent than other topics. So, matrices, for example, every exam. But this here, not every exam.
Graphs are almost
I'd say there's always one graph per exam, yeah.
but it's in part B. Usually, yep.
No, sometimes part A.
I thought that it's usually part of
No, it is usually part B, but I'm saying it's possible for it to be an A. So anyways, when we get to the end of the semester, we'll talk about which topics maybe are frequent or not. So what I'm saying is, it's not like this is a topic that's only come up once.
You can just take a look at the Moodle for the past.
Yeah, you have the Moodle account, don't you? Yeah. I think the past exams are at the bottom if you want to have a look. Anyways, let me give you one to try here. Which one did I end up doing? Was it like the
A.
first one, was it?
Yeah.
Okay, let's see which. I would. Yeah, you know what? Just try B for me now. I want to make sure you can do that one. B, yeah. 4B. Yes, 4B. Yes, you can use your calculator to help if you want. Okay, do we nearly have it? Okay, well, if you're working on it, you can continue to work on it, but I'll do it here too. Minus that one, and then that one. And then that one there, and that one there. I think I'll try to simplify this a little bit first. That'd be 101 times, no.
This is 63 root 14.
It has a 63 in it?
Yeah,
63 root
14.
14, okay. And then
No,
here,
no, no. This
Six
is
root
6,
14.
sorry.
Six root 14.
what is it?
It's 6 root 14.
6 root 14, okay. Minus 7 minus root 14. Multiply. Minus 7 plus root 14. Minus 7 plus root 14. So, I'll do it all together. On the bottom, I know I will get 49 minus 14. And then on the top, I will get 63 multiply 7 minus 63 root 14 minus 42 root 14 minus 42 by 14 plus there. So what's that? 63 by 7 plus 42 by 14. It's going to probably be a big number, is it? 4219?
The last one is 6 times 14.
441.
Mr. Steven,
Yes?
it's not 42 times 14, it's 6 times 14.
Thank you, 6. Oh, so is that wrong, or is that 441?
This is correct.
That's it? Okay. Minus 105 root 14 all over 35. So 30.
No, you forgot to plus 625.
Whoa, slow down there. Slow down.
It's like 525 minus
What?
1.
Hang on. One at a time.
400.
Wait. Sultan.
525 minus 105 square root of 20.
Where are we talking about?
Yeah, all this time.
Wait. Sultan.
And the answer of the
Here.
Yeah.
What am I missing?
It's 525.
525 minus 105. This is the final answer of the denominator.
No, this is correct.
No, this is correct. The final answer. Yeah, that's it. That's it.
Yeah, but never mind. I'll just use a calculator. I don't trust anyone anymore. 63 by 7. Yes. What?
6 times 14. 6 times.
Not 42 times 14.
Oh yeah, but I thought I fixed that
You
with my
undid
pen.
that.
Oh, I pressed Control Z. Stupid Control Z. Right. 6 times 14 plus 63 times 7. 525. Now we're happy. Minus, this is still 105 root 14. And then this here is 35. Now, I do wonder if 35 goes into each of these. 525 divided by 35. Yes, 15. And then 105 divided by 35 is 3. Root 14. Now, listen. Well, hang on, what mode is this? If you have the Casio 991, type this question in the calculator directly. So
It wouldn't give you
The answer is correct.
you're all wrong. If you type the question in the calculator and press equals, it gives you the answer. See?
It would give you like 106 points.
No.
I have it right in front of my face and I can
Well,
see
right.
the answer.
Give me.
Look! Look! Now see, it doesn't work on these.
That should be correct.
It simplifies it for you.
It is, man.
Yeah, change it.
What was it before, man? What was it before?
So you gotta type the question in and press equals. It simplifies it. Does it do that?
Thank you.
It does. Like when we type it in, it will simplify Yes, yes, yes. I don't know about this one or that one, but just on that one, yes. Yes. No calculator?
You said no.
Okay. All right, it's fine.
I don't know what I went wrong.
Now, that calculator, no.
No.
Now look, in the exam, I'm telling you this so you can check your answer. But if the question was there and you just use your calculator directly and get the answer, you get no marks. Now I'll say that again because it's important. Now be quiet. If you just did this on the calculator directly in the exam, this type of question, that's no marks. Okay? I'm telling you, you can do it on your calculator so that in the exam you can check your answer and make sure you got it right and you got full marks. The same, I think, is true with the multiplying. If you put in the two terms and press equals, it should simplify also. Okay? Again, I'm telling you this so you can check the answer. If you just use your calculator directly, then it's no marks. Okay? Now, of course, you can use your calculator on each step. You know, if you have numbers to multiply. I'm just saying you can't jump to the answer. Okay? Yes?
What about like factorizing if they were big numbers?
Yes. Yeah.
That's fine.
That's fine. Yeah. You mean like the square root 604?
No, the previous lessons factorizing. Like if I had like
yes, okay.
because you don't have steps in that.
You're right, exactly. So you could be fine using the calculator for that. Yes, yes.
Yeah, but here you have to.
Yeah, there are steps. Yes, and the steps, I need to see them to give you the marks. Okay. What is the problem, by the way? No problem? Yeah. So you buy the calculator I asked you to buy, and then no problem. It's very difficult because you will need the calculator for some questions, like later chapters.
Don't you want?
Like that.
Here.
15.
Oh, just do them individually. Like 5 to 5, 5 to 3, sorry.
There, yes.
15.
Why did we multiply
Like 4, 5,
7 plus 4
3.
First step.
The
Just
top?
try. You can't.
Oh, that's the conjugate, remember?
Yeah, why do you have to do that?
Oh, because if you didn't, there's nothing to do. Like, the question just sits there. You need something to start the simplifying process. So that's the only thing.
You have to do this to eliminate
The square root from the denominator. Yeah. Okay, so the questions I'd like you to do. The questions I would like you to do page 22.
Just give us 3 questions.
Shh. No talking. I'm thinking. Yes. All down the side. Why again? You see, you're not learning. If you annoy me, it just makes it more painful at the end. Stop annoying me.
At
I
least
said
question.
annoying. I said annoying.
Could we do like half or 3/4 of question 3? Just question 3 alone, like everything else.
Yes. You can do half the ones in number 3. So you could do STUVW. Oh no, how many are there? 1, 2, 3, 4, 5, 6, 7. Yeah, STUV. I'm too kind, I know. It's my weakness. So, just to be clear, I want in question 1, put that bag back on the ground. Question 1, I want y and z. Question 2, I want w, x, y, and z. Number 3, I just want s, t, u, and v. And then in number 4, I want u, v, w, x, y.
Thank you.
Too kind.